Times 2. What's another word for something when something is times 2?
Double.
It doubled. So I would write down here the distance doubled. I would really hope every single pencil was moving except for the 3 people who I saw already had that. The distance doubled. I think you're ready for this, even though we haven't talked about it. A scale factor is the number you multiply by to get the new figure. What do you think the scale factor was here? Think about it for a second. What was the number you multiplied by to get your new shape? Did you know it? Say it.
2.
Good. So put the distance doubled because the figure was dilated by a SF of 2. I'll say it again. Because the figure was dilated, that word is in your prompt as well, dilation, by a scale factor, SF of 2. Now I want you not to cheat, and I want you to play a game right now. I want you to only do the things I ask you to do. Right now, I just want you to do the best you can to measure the distance from A to C original, the side I just highlighted here. All you're doing now is measuring the distance with your ruler from A to C. A to C. Anyone find it? Is it inches or centimeters? Inches? What'd you get in inches? How many? What?
1.
1 inch? Okay. Now do not to cheat right now. Do not use your ruler anymore. Stop. If that is 1 inch, what is this going to be and why? If this is 1 inch, what will this be and why? Yo, some of these hands I see up right now, obviously you have effort scores like Pinky calling the same person. I have not heard from Layla yet. She's in the back.
I think it would be 2 because we said that the scale factor is 2, so 1 times 2.
Great. This is 2 inches. What if the original space was 6 inches? What if A to C original, Kizzy? What if A to C original was 6 inches? What would A prime to C prime then be if the scale factor was 2? Think for a second. I'm going to keep challenging you. If it was 6 originally, what would the new one be? If you know it, say it. Pass that. I think more of you can join in by now. Now, if it was... What if I gave you a figure that started at 6 and said the scale factor was only 1/2 though? If the side started at 6 and I gave you a scale factor of 1/2, now what would the new side be? Sam. 3. What did she multiply 6 by to get 3? So you multiply the number of the side by the what? It's a new word. What is it? What is it?
Scale factor.
There we go. Okay. So, what is the scale factor for this dilation? Explain how you know. What is the scale factor for this problem right here? If you know it, say it. Okay, so the SF is 2 because, can someone think of some evidence? Malik, Stephen, a few people shared measurements of this already. Can someone think of evidence for how we know the scale factor is 2? How do we know the scale factor is 2? I see the people with the hands up, and I know you probably know already. Keep waiting. I appreciate y'all. Tyrell.
The distance is double.
The distance doubled because distance between, let's say, what did we measure from originally? From point O, so let's say distance between O and points doubled. Who can give a specific example to prove that? Because distance from O and points doubled. Give a specific example to prove that. You give Malik +1, Stephen +1, Miriam +1, Isaiah +1. They kept having their hands up. Ask that.
O to A, and then O to A prime.
Perfect. So, for example, O to A equals how many inches? 1 inch. O to A prime equals how many inches? 2 inches. Okay. So you're not going to be able to read that at all. I'm going to read it myself. So put, for example, O to A equals 1 inch. O to A prime equals 2 inches. You know what? This is not the most exciting way to do it, but I think it's the most successful way for you guys right now. You still have those math notebooks? Yeah, the graded paper. Take like 30 seconds, get those out real quick, open up to a blank page. If you don't, you can borrow a sheet from somebody. That's fine.
What was this? Huh? 20 minutes.
You just put it somewhere. All right. That's okay for the gym. How you also tired? I don't think you guys need to work out, need to do. Okay, great. We're gonna have to do a lot of like movement and partner work in a second. We gotta get these notes down first though. So take your pencil, write the word dilation. Put an underline on it, dilation. You can see that. There's a few things we're going to say. First off, and I'm just looking to give like credits, or I mean points right out to people, so I guess your participation points for today, so your effort, those be going by hand. So Kizzy just put a plus next to the people's names as they contribute right now. How is this different from other transformations you've done before? Jakai, first hand up.
Because when you dilate a figure, it's not going to be congruent.
It's not going to be congruent, you're right, because what changes? Someone else. What changes here that had never changed before? Isaiah.
The scale factor?
I think, let's be a little more specific, Melanie. The measurements, that means that the figure what? What about the figure change? You're right, the measurements that change them. Not the shape, but it's what? It's still a triangle, but it got bigger or smaller, so it changes what? Size. If size changes, what else changes? Oh, now think. Take your pencil, go with your partner, go to the bottom of this page, list everything that changed and everything that didn't change. What was preserved and what was not preserved. Right, take 30 seconds, go ahead. Did that change or not change? Good. Good, Cornelia. Good. That did change, right? Good. Okay. Keep writing. Don't worry, half it's in your hands. You're gonna get it right. Don't worry. Yeah. Did change. Between points, bigger, right?
Size, location, distance between points. It will stay the same as the orientation and the shape.
All right, bring it back. 5, face forward. 3, 2, 1. Put a +1 next to Malik and Layla. They jumped right to it. Danelia and Melanie, they jumped right to it. A lot of groups did. Look for people who just like immediately I heard them talking about the stuff they're supposed to be talking about. We're going to list those in a second. Write the definition of a dilation is this. Is a, I'm going to actually try to write neatly so you can read it, is a transformation. You're not taking a lot of notes today. This is pretty much it. It's just this one definition. Is a transformation that increases or decreases size based on a scale factor. The last part of this definition is the figure or shape, whatever you want to say, the shape, figure shrinks or expands from the center of dilation. We're going to talk about what that means later. It's a transformation that increases or decreases size based on a scale factor. The figure shrinks or expands from the center of the dilation. And then put operation equals times SF. You just multiply whatever you're going to look at, distances, things like that, by the scale factor. We'll talk more about how to apply that in a second. Operation equals times or X scale factor. Change, preserved. Kizzy, you can put +1 next to your name just keep track. Hashtag, you're the first person to tell us this one thing, change or doesn't change. Go ahead.
Okay, so the first thing that changed is the distance between the points.
Okay, so change distance between points. Anything else change or doesn't change? I don't care. You pick one. I'll let Jaden know. Perimeter. Perim changes. Anayali. Location does change. Good. When it gets bigger or smaller, it can't really be in the same exact spot anymore. So location does change. Good job seeing that. Anything else, Stephen?
The shape.
The shape doesn't really change. We started with a triangle and we ended with a bigger triangle. Make sense? So the shape is actually the same. So we're going to go to preserve. Then you were saying that. Put preserved and put shape. The shape is still the same even though it gets bigger or smaller. Jakai,
Orientation.
does that change or stay the same?
Stays the same.
Stays the same. Who else had that? I know Malik, you had it. A few people. Yeah, orientation is preserved. Anything else? I'm going to try to call someone I haven't called in yet. Geo. Area changes. Stand up, anything else? That was yours. Shape, orientation, distance. Okay. JC. You already had perimeter. I didn't really spell it all the way, but okay. Danelia. Stays the same or changes? Nope. If a rectangle is small and these sides are parallel, then I grow it out, these sides are still parallel. So I actually preserve, you can put parallel sides. You need to think really hard about this. I'm going to draw a picture. You do not need to draw it. Pretend that I drew this better than I did. What shape is that? Square. It's a square. Now, if I draw one that's 2 times as big, something else didn't change in here. One more thing didn't change. One more thing didn't change. Put +1 next to Ty, +1 next to Jakai, +1 next to Jaden and Malik. I see JC put +1. I see you thinking, like, what's the one other thing that didn't change here? I'm gonna give you oh, Sam got it, put +1. What is, you think you have an idea now? If you think you know it, say it. Angles. Angles actually don't change. People always mess that up. So if an angle starts off at 60 degrees, and I dilate that figure by 100 and it gets way bigger, what is the angle still going to be? Be what? 60 degrees. Angles do not change. Please try to memorize that. Angles don't change. I think that's it. You want anything else? I can't think of anything. I might have missed one. Pass that. How did I not put that? You're right. All these things mean, obviously, put a big star. The main thing is size. Size changes. Distance between points, perimeter, location, area. Well, besides location, when all that stuff changes, it's because the size changed. All right. Turn the page. Put this aside. You can keep it. You can use it for later. Anyone want my notes? Did I say great notes? Here. Take them. All right. We're doing an example together. Take your ruler. Read the prompts. Malik, loud so everyone can hear it. Everyone else, pause for a second. Look up here. I'll wait one more second for you to turn to that page if you're not there yet. And find 2 things you think are important to annotate here as Malik reads. There's 2 key things you need to find every time. Malik, go ahead.
Dilate the figure below by a scale factor of 0.5 using point A as the center of dilation.
What do you think are the 2 things we need to take note of here? Obviously, it's a dilation. Don't give me that. Okay, great. I want 2 more things. 2 more things here. Scale factor. So put a box around that and put SF above it. Box the scale factor, Melanie, and put SF above it if you didn't already. What's the other thing, JC?
I labeled point A as center of dilation.
Great. Circle that. Center of dilation is this COD, C-O-D, center of dilation. Okay. So, our figure, is it going to get bigger or smaller based on this scale factor, you think? Why do you think it's going to get smaller than the other?
Because it's a fraction.
It's a fraction. We're multiplying. This should give like 1 minute. Tyrell, can you do this example real quick? And you can go ahead. All right. So we're going to go by 1/2. And what's the point that we're shrinking from? A. Put the corner of your inches for A, or like on your rectangle, on point A like this. Now, you know what? This is like the one time I'll actually accept this. We'll see if we can get this better. No, we can't. All right. I want to estimate this as round this to 2 inches. So this distance is 2 IN. Round the distances from A, or the A to D right now, and raise your hand when you know it. Find the distance from A to D. If it's really close to 1.5 inches, put 1.5, whatever it is. Naya professionalism, Messiah professionalism, Stephen professionalism. You're pushing the pace a little bit, Melanie. You got it? What's the distance from A to D, Melanie? Okay. So this is about 1.5 inches. What's the last point I need to measure to though. What's the, everyone should know. Well, we measured to 2 points. We already know A is not going to move. What's the 1 point we need to measure to now? If you know it, say it. C. I need to measure diagonally across to find C. And the distance here, I wouldn't say 2. I would say 2.5. So I'm going to draw a line like this and put a 2.5. Looks good, looks great, Kizzy. Looks great, good, good. Perfect. Just label the last part, half cent diagonal. If you get the diagonal here. Good, good, great. All right. If the scale factor is a half, the new distance from A to B should be what? Okay, slow down. What operation did we say we're supposed to do? Multiplication. If it started off as 2, and we multiply by a half, what are we going to be left with? 1. So the distance from A to B prime should be 1 inch. So I'm going to measure that out and put B prime right here. Emily, actually now, can you turn, or someone, can you turn the, Cassie, can you turn the lights off? Make sure you put B prime right there. What is half of 1.5? Point what? 0.5? No. 0.5 is half of 1. 0.75. So take your ruler again, and now from A to D, go from A, start from A and go up to almost an inch, go to 0.75. So that'll be right here. And that'll be B prime. How's that? 0.75. So it's like 3/4 of an inch. And then the